Here we have our model of an atom. Again, it's not to scale, and it's only a representation. In the middle, we have our nucleus, and around the edge in shells, we have our electrons. Our electrons aren't shown to be moving, and this wouldn't be the case in real life. They would be moving fast. What we're going to show is what happens when we fire different ionizing radiations at an atom and see what happens to this atom here. If you want to look it up, this atom has 1, 2, 3, 4, 5, 6, 7 electrons, so 7 protons in the middle. So if you look up element 7, you can see what atom it is. Here I'm going to fire a low energy alpha. We know that an alpha particle is 2 protons and 2 neutrons. Watch what happens. As you can see, the alpha particle goes towards the atom. Its influence is stronger than the nucleus, which is so far away. So this electron is pulled towards the alpha particle and escapes the atom. This atom now has 1 less electron. It has become an ion. Let's see what happens when the alpha particles have higher energy. Here you could see that the electron is pulled towards the alpha particle. As the alpha particle spends so little time passing the atom, it doesn't have enough time to pull free the electron. The atom remains as it is. Let's see what happens when we fire beta at an atom. A beta, as we know, is an electron, but is not an electron that's come from the shells. It's an electron that has arisen from the conversion of a neutron into a proton. Here's a low energy beta. You can see that the electron in the atom is repelled by the beta particle because they are both negatively charged. The beta particle's path is diverted and the electron is free. Again, we end up with a positive ion. Let's see what happens when we send higher energy beta towards the atom. Here you can see that the electron from the atom is again repelled by the beta and it sets off in its own direction. The path of the beta isn't changed very much, but it will have been slowed down. Here's the highest energy beta. Again, very like the high energy alpha, the electron in the atom is affected by it, but the beta is not spending enough time in the vicinity of the atom to cause this electron to break free. We're now going to show what happens to gamma radiation when that comes in the vicinity of the atom. This is low energy gamma. Here, the gamma is absorbed by the electron gains energy, and the energy it gains is enough to free it from the atom. We are left with a positive ion. If we fire higher energy gamma at this atom, the electron absorbs the high energy gamma and the electron is free to leave the atom. If you notice, the energy, the kinetic energy, the speed of that electron was faster. We're left again with a positive ion. I'll just show these once more very quickly each time. Low energy alpha, high energy alpha, low energy beta, high energy beta, highest energy beta, low energy gamma, high energy gamma.